Yeah, so question 24 from the practice exam, right? We're given the information. We're going to make a 1 liter buffer by mixing together 375 milliliters of 0.5 molar hydrogen cyanide. And we're going to mix that with 625 milliliters of 0.5 molar potassium cyanide. So HCN is a weak acid. Potassium cyanide is the conjugate base of that. So we have a buffer. Right, so we add those two together, we're going to have 1,000 milliliter solution, right? They tell us that, but our concentration, right? Concentration is moles per liter. So as we add both solutions together, the volume changes, my concentration changes as well. So we're asked to find the pH of this new solution. I need to find my new concentration first for both of those. So do the calculation for hydrogen cyanide, do the same calculation for the potassium cyanide, right? M1V1 equals M2V2. So my original concentration is 0.5 molar. My original volume, 375. My new concentration, that's what I want to find at my new volume of 1,000 milliliters. Same thing for potassium cyanide. 0.5 molar, 625 milliliters. What's my new concentration at my new volume of 1,000 milliliters? So the hydrogen cyanide comes out to be like 0.1875 molar. And the same thing for the potassium cyanide, and I get about 0.3125 molar. Now that I know my new concentrations at my new volume, now I can find the pH, right? Using the Henderson-Hasselbalch equation, pH equals pKa plus the log of concentration of base over the concentration of my acid. So that's the last step, right? pH equals pKa is the negative log of Ka. The Ka of hydrogen cyanide is 6.2 times 10 to the minus 10. Like I said, it's a really weak acid. Plus the log of the concentration of my base. My base is the potassium cyanide. That's the conjugate base, right, of hydrogen cyanide. So 0.3125 goes on top, and the 0.1875 goes on the bottom. pH of this solution comes out to be something like 9.43. So anytime we're mixing two different volumes together, we should think of M1V1 equals M2V2 to let us say, all right, here's my initial concentration at this volume. Here's my initial concentration at this volume. I mix those two together because my volume changes, but the number of moles that I have in solution doesn't change, right? My concentration will need to change as well. So M1V1 equals M2V2. Found my new concentration for both. And then I can just plug that into the Henderson-Hasselbalch equation to find the pH of this buffer from there. Yeah.
So why would you need to convert from milliliters to liters?
Yeah, you don't need to convert milliliters to liters here because you can if you want. You're going to get the same answer because essentially the use units cancel out because you have milliliters on this side, milliliters on this side, so it doesn't matter. It's fine if they're both milliliters. If you converted them both to liters, you're going to get the same answer. We're just solving for the concentration. Yeah.
So there's a short answer on the question, but that doesn't change.
Correct. Yeah. Yep.